So as we proceed forward with these 5 examples, a common question gets asked, like for instance that first one. That would be what we call phosphoric acid if it's if it's in an aqueous state. And what that means is we try to illustrate when we're doing these dot diagrams, say, well, you start with carbon. If carbon's not there, well, then you start with nitrogen. If neither one of those are there, then you'd start with a metal. But in this case, you don't have any one of those. You don't have carbon, you don't have nitrogen, and you don't have a metal. But when you're looking at a compound like this, you would choose the one that has the least number of subscripts. So in that formula, which element has the least number of subscripts? Which one? We're just going to work from the top down. Phosphorus, that's right. So upon doing that, this is where you look at the periodic table and what column is phosphorus in. Am I recording this? Okay, I think my batteries have just about had it, so I'm going to quickly switch them. Well, let me get you started and then it'll make sense. So you correctly said 5, okay? 1, 2, and typically what you do is you put 2 on each side. You might say, well, you go 1, 2, 3, 4, and then that last one's going to end up there. I'm going to run out of space if I don't lower that. That's right, I'm just moving it down. Like if you did 1, 2, 3, 4, they're still going to end up together. All right, so remember, you're still trying to satisfy that octet rule. The phosphorus is out of the way. The hydrogens are known as proton donors, so they want to be on the very outside. So looking at this, what element do you think would come next? Oxygen does, okay? So since these don't have any electrons matched up yet, that's where those oxygens would end up. We'll make a bond here. And oxygen's in what column? Okay, so there's 1, 3, 4, 5, and 6. So there's 1 oxygen. Now what? We're down to 3. So if we made a bond with these dots, what do you suppose you're going to do with these 2? Same thing. That's right. Okay, so we'll make a bond there. Okay, same thing here. Okay, now you might be looking at that thinking, well, we've got 1 oxygen left. This is going to be what we call a coordinate covalent bond. Okay, when covalent bonds are made, what are those electrons doing with one another? They're sharing. In this case, kind of going back and forth, kind of like playing ping pong with one another. So in this case, we can do this. Okay? Now, is this oxygen satisfied with 8? Yes, 2, 4, 6, and 8. What about this phosphorus? 2, 4, 6, 8. Okay? But these 3 oxygens, but we got 1 at bat left, right? Yeah, you're correctly saying hydrogens. So what's going to happen, okay, and this is what it does, is we've got a hydrogen here, hydrogen there, and a hydrogen there. Okay? Have we accounted for all the elements? Yes. Have we satisfied the octet rule for all of them? That can be satisfied. And the answer to that was yes. Which one can't satisfy the hydrogen? Because it only has 1 electron to give away. Okay? So when you first saw this, And now you look at it, that doesn't seem so hard. But that's because you didn't know how to do it. Now you look at this, that's really not so bad. The reason we say that is we can do another common acid, and I'll see if you can do that. It is, we'll call it H2SO4. And I want you to work on that for just a moment. Then I want to get through these with you still being able to understand and yet giving you the maximum amount of time to work on these papers. So go ahead and look at that H2SO4 and we'll discuss it in just a moment. Okay. So how many of you would be looking at this and just say, I don't have a chance? I have no clue, and I'm not even going to make an effort to do so. Well, keep in mind, 2 years ago, was it Loyola College? It was Loyola something, beat Virginia.
It was UMBC, University of Maryland.
Why am I thinking Loyola then?
Because they were like an 11th seed that made it to like.
Okay. So, yes, that UMBC. What happens? A 16 seed knocks off a number 1. So, what would that be like if you're a 16th seed? You go into this tournament and say, we don't have a chance. Why even go out and play? Then they never would have been able to illustrate that, hey, we're actually pretty good and knock off a number 1 seed. Okay, so which element do you think you would start with in this compound? For the same reason, just like you start with phosphorus, now we're going to start with sulfur. Okay, so sulfur is in which column? So if you did something like this, I mean, that's fine. But the best way, and there's no way of knowing this is probably the best way. So how many of you drew something like this? Or just as long as you have 6 electrons around it. That's all we care about. Okay? So we can do that. So now, these two need to be bonded to something. So what could we do? Put an oxygen on there, right? One there, one here. Okay. Now, what are we going to do with these two? They're going to share just like what we did up here. You'd put an oxygen there. And then up here as well. Is sulfur happy? Oxygen? Oxygen? Yes? Oxygen? Needs another hydrogen. One there and one there. And that would be how you do that compound. Okay? Can I erase well, this one we can for sure. Okay? All right. Can we close the door on this guy? Okay? Well, how about C3H4? Again, here we're going with the idea, do you want to see how you actually would do it or the natural progression you probably would take? How you actually do. Okay. So with this, what's actually going to happen, what carbon has to go in the middle, and what can carbon do that the majority of other elements can't do? Or double bond. So in this case, it's going to do a triple bond. Okay? So if we have 3 electrons here, we have to put 3 here to illustrate that triple bond, just like this, like you had correctly said. Those mean the same thing. So how many more dots does this carbon get? 2? Okay. I hear 2 and I hear 1. Yeah, because it's in column 4. We've got 3 of them here. Here's that 4th one. What about this carbon? Has 1 more. Okay. So we've taken care of 2 of those carbons, and we have how many left? Just 1 more. So let's make another bond here. How many more electrons does this carbon have? 3. Okay. So how many electrons are around this carbon? 7. Because it's triple bonded, and it's got 1 on the left side. How many more electrons does it want? Where might it get it from? Hydrogen. Okay, so we'll go ahead and put a hydrogen here. All right. So how's this carbon doing? There's 8. Yeah, fantastic. Well, what about this carbon? He's doing well as well. I don't mean to be redundant when I say that. So, but this one is still short yet. It's got 2, 3, 4, 5. But how many more hydrogens do we have to deal with? 3. So anywhere where there's a triangle, what are you going to put? So how about this carbon atom now? Satisfied. Yep. Or optimized, or legitimized, or satisfied, rectified the situation. Any more I's? No, can't think of any. Okay. So now we can erase this one. And again, you might think I'm going fast, but again, we want to give you the maximum amount of time for this. Okay. Can we erase that C3H4? Okay. That we're going to do. Okay. What type of bonding do you suppose this is? Notice we didn't give you the formula. What type of element is cobalt? It's a metal. What about the chloride ion? It is, therefore making it a what then? Well, yeah, you're putting 2 concepts together. It's a halogen, it's a gas. More importantly, it's a non-metal. Okay, everything you said is correct. But when you look at that, how do you know how many electrons cobalt has to give away? It's a transition metal. Okay? But what type of charge is this cobalt forming? +3. So that must mean it has how many electrons to give away? 3. Now, we can base that off of this guy right here. It's very similar. Aluminum is also in column 3, right? So how many valence electrons is that? So if this forms a +3 charge, which it does, that must mean there's 1 there, 1 there, and there, 1 there. And that's what it would look like. But in this case, if we have cobalt-3 chloride, cobalt has how many valence electrons to give away? And the chloride ion, either being a halogen, a nonmetal, or whatever in column 7, has how many valence electrons? 7. So 7 plus 1 is going to give you what? That's right. So then, so on and so forth. Then you'd put that last one in there. Okay? Outside, how are we doing so far?
Fantastic.
Okay? Left middle. Okay? Middle. Right middle. And right outside. Okay? Then of course you just put this last chlorine in there. And then you got that one done. Okay. Can we erase this? Okay? Notice that's not an ion. Chlorine, that's an element. But it was one of your vocab terms. What's true about gases and halogens? What does diatomic mean? Yeah, so this is actually a simple molecule. Chlorine is in which column? Well, we just showed you that here. Yeah, so here's 1, 2, 3, 4, 5, 6, 7. Okay, how many short is this chlorine atom? 1. Where's it going to get that other molecule or other electron? Because you had correctly said it's diatomic. That's what diatomic means. Here's 1 chlorine. So then how do we bond that to the other chlorine? This one's got 8. This one's got 8. Okay? We've just made a simple covalent bond between the two. It's covalent, it's not coordinate covalent. Okay? Does that last one, it probably looks like it's really tough, sodium hydroxide, but how many of you could just punch that out just like so, just like that? I bet you could if you see the formula. Okay? Well, what's the symbol for sodium? Nah. Nah. Yeah, I get it. So, okay, what's the formula for the hydroxide ion? Okay, what's the charge of the hydroxide ion? What's the charge of sodium? Do those add up to 0? So you don't need to change anything in that formula for subscripts. So, upon looking at this, none of them have anything more than 1 in their subscripts, but we have done this compound before. We just never done it with sodium. We've done it with hydrogen. You've done it with potassium. You probably have done it with lithium. But now we're going to do it with sodium. So you got a 33% chance. Which element is going to go in the middle? Which element is going to go in the middle? Oxygen, because it's in what column? It's in the 6th column. Okay? 1, 2, 3, 4, 5, 6. Or if you went 1, 2, 3, 4, 5, 6. Either one of these is going to be just fine. Okay? Because this one's got 6 dots, this one's got 6 dots. Which one can I erase, the left or the right? Erase the right one. Okay? So this oxygen's got 6, it needs how many more? Where's it going to get them 2 from? The hydrogen and where else? Okay. That is sodium hydroxide. And the reason for that is metals are proton donors. Okay? Or excuse me. They give away their electrons. That's what I meant to say. So that's why they're here on the outside, so those electrons can be stripped off of there. Yes? 63.55. Okay. We got more dinosaurs in here. I like doing that. I give students a hard time when they ask questions like that. It's not the verbal message. It's this.
What did you say it was?
Dinosaur.
63?
63.55. I'm sorry. I'm making fun of you. I shouldn't do that, but it's still funny. Why are you a dinosaur? It's the way you ask questions. Look like a Tyrannosaurus Rex. Okay. Okay. Yes. Anyways. Moving on. If you had a really good understanding of this, tomorrow is just going to be one of those aspects you just going through the motions. The reason we say that, you still have to go play the games. You still have to go to your competitions. For those of you who are in music, you still have to go to the auditions. Because one of the things that you will notice that when you do go off to college, not everyone gets to participate in activities. And that's good. It makes you work harder. Okay. Any questions on this? Okay. So can I erase this? We got time for one question on your paper that you might be looking at and just saying, I don't get it. Otherwise, the rest of the time's yours. But regardless, by giving you that opportunity to ask, I don't get it. Okay, sorry for that interruption. Anyone have something that you want to go over as a group, and we'll knock that out really quick. Going once. Going twice. So, rest of the time's yours. So, we will catch up to you next time.